Hello and welcome to part 12 of our video lesson in computer network. Today in this video lesson we'll be talking about MAC address and different types of IP address. MAC Media Access Control or MAC address is a 48-bit address that is used for communication between two hosts in a network. Now for example, if you want to communicate from your laptop or your computer to another computer, you need to have certain address in order to communicate. So we use this MAC address for communication. Your laptop will have certain MAC address and your another PC or laptop with whom you want to communicate will have another MAC address. Now this MAC address, it is a hardware address manufactured into every network card, like your network interface card, which is available with your PC, such as Ethernet card or Wi-Fi card, and therefore cannot be changed. So this MAC address, once it is manufactured, it cannot be changed. That is why this MAC address is supposed to be globally unique. MAC address is also known as a hardware address or a physical address. A MAC address is made up of 6 2-digit hexadecimal numbers. In total, 12 hexadecimal digits separated by colons. So MAC address is separated by a colon. For example, if you see in your laptop, if you search for your MAC address in your PC or laptop, you will see the MAC address is separated by a dash. But if you see in your mobile phone, you will see the MAC address is separated by a colon. For example, consider the following MAC address: 012225E7F 8C and CD. Now in this is the MAC address. This is how a MAC address looks like. Now if you see between 01 and 22, there is a colon is there. So that means it is a MAC address which is separated by colon. Now when I say hexadecimal number, now if you count the total number of characters in this MAC address, that is 012225E7F 8C and CD, in total we have 12 characters. That's why we call here as a 12 hexadecimal digits. Now the first three numbers, that is 01, 22 and 5E, are the organizationally unique identifier vendor number. Now what is this organizationally unique identifier vendor number, or OUI? What is this OUI? It is a number created by a vendor, say for your laptop like Lenovo, Dell, HP, or your Apple. These are nothing but a organizationally unique identifier vendor number created by them or manufactured by them. And the next three numbers, 7F, 8C and CD, are the network interface controller specified serial number. So suppose how you may think how the address or the MAC address is globally unique. Say for example OUI, say for example for laptop, they'll be given specific first 3-digit number. Say for example for Lenovo, if it is given 01225E, this is for Lenovo. And for Dell, say suppose OUI number is given as AB225E. So in that way the address becomes unique. Now IP address version 4 and version 6. Every computer in a network has an IP address by which you can be uniquely identified and addressed. Say for example your laptop or your mobile phone. When you communicate over the internet, your IP address is used for communication over the internet. And IP address is a layer 3, that is a network layer, that is, it is a logical address. So this address is not manufactured by a company. This address is given to you by the website. This address may change every time a computer restarts. For example, right now when you're viewing this video, IP address may be different, and when you switch off and switch on again the IP address after if you view the same video, IP address may change. A computer can have one IP at one instance of time and another IP at some different time. So IP address always get changed every time you browse the internet. Each machine in a network has another uniquely identifying number or unique 32-bit, that is 4-byte address termed as IP address. Now say your mobile phone or your laptop. Now each device has a unique, that means it is different from one another. It will have unique IP address, which is a 32-bit address, and this is termed as the IP address. IP address are usually represented in a dot decimal notation. 4 numbers ranging from 0 to 255 separated by dots. For example, 191.77.188.166. So if you see in this example, this is a typical example of IP address, how it looks like. Now if you see here, it is separated by dot. Now when I say 32-bit, it means 191 will have 4 bytes, that means 8 bits. 77 will have 8 bits, and 188 will have 8 bits, and 166 will have 8 bits. Total combining, we have 32 bits. So IP address is a 32-bit address, whereas MAC address, it has 48-bit address. Now let's see in deep what is this IP address. Now as I said, IP address is a 32-bit address. So IP address format, it looks like this. It is divided into network ID and a host ID. Now network ID is divided into two 8 bits, and host ID is divided normally into two 8 bits. Here 145.10 is nothing but the network ID, and 34.3 is nothing but the host ID. Now depending on the type of classes, we'll see these types of class in the next video, or in the coming video. We'll see what is these types of classes in IP address. Now basically here network ID is IP address is differentiated into network ID and host ID. Now what is this network ID and host ID? Say suppose in your practical lab, there is a one server computer is there, so he is nothing but a network ID, and this server is connected to all your computers in a laboratory or in a computer lab. So these are nothing but a host. So we have server and a host. So server may contain network ID say 145.10, and a host say you're using a computer for your practical in the practical room. These are nothing but the host ID. Each computer will have different host ID. Maybe at the end you will have different numbers. So each will be unique in their host ID. Network ID may be the same or should be same, but the host ID changes from one computer to another computer. Internet Protocol version 4, or we call it IP version 4. IP version 4 is a 32-bit addressing scheme used as TCP/IP host addressing mechanism. Now we learn about TCP/IP in the next coming videos. IP addressing enables every host on the TCP/IP network to be uniquely identifiable. Now IP address, it is a 32-bit addressing scheme. Now TCP stands for Transmission Control Protocol. So what happened here is that it enables us to control the protocol, the movement of the network. Now this IP address enable every host. Say suppose you're having a practical room in your computer. You're having a computer practical room. You have a server and a host. Now it enables a host on a TCP/IP network to be uniquely identifiable. Say for example, in your computer practical room you have 24 computers and one server. So how to uniquely identify that 24 computers are different from each other? We identify these 24 computers are different from each other by their IP address provided by the computer. Now IP address are divided into many categories. Now class A, it is a first octet for network address and the last 3 octets for host address. Now what does it mean? Normally IP address consists of 32 bits, each representing 8 bits each. Now when I say octet means 8. So the first 8 bit will be network ID and the rest 3 8 bits will be the host ID. Now for example, in our IP address 145 dot in our IP address 145.10.34.3. Now this is a typical IP address format. Now if it is class A type of IP address, now 145 will be the network ID that is used by the server, and the 10.34.3 will be the host ID that will be used by the different computers. Now this IP address may change, 10.34.3 may change, but 145 will remain same for everyone. This is class A. Now class B, it uses first 2 octets for network address and the last 2 octets for host address. Just like class A, the first 2 8 bits will be used for network ID and the last 2 8 bits will be used for host ID. Now in class C, the first 3 octets used for network addresses and the last one for host ID. Say for example, the first 3 8 bits will be used for network ID and the last 8 bit will be used for host addressing. Say for example, the IP address is like 145.10.34.3. Here 145.10.34 will be the network ID and the last 8 bit number 3 will be the host ID. Normally when we use in our practical room, we use this type C IP address where only the host ID will change from one computer to computer. Now class D, it provides a flat IP schemes in contrast to a hierarchical structure above 3. So it provides a flat IP schemes. So normally we don't use this class D type of address that much. And the last type of IP address is type E. Now type E address is used for experimental purpose only. It haven't come to our network. Internet Protocol version 6. IP version 6 address is node with 128-bit address, providing plenty of address space for the future to be used on the entire planet or beyond. Now this IP version 6 is used, or it has been set up so that if IP version 4 has been expired or it has been stopped, then we can use IP version 6. So it is a 128-bit address. Since it has plenty of space, so then it can be used for the future on entire planet or beyond. Now IP version 6 has introduced anycast addressing but has removed the concept of broadcasting. Now what does it mean? In anycast addressing, IP address will be same for all the computers. So what happens when a computer wants to send a message to a particular computer? It will send to the nearest computer. It will not send to the far away computer. It will send to the nearest computer having the same IP address. So it has introduced this anycast but has removed the concept of broadcasting. Now this is broadcasting. If you remember Hub, now what happened in Hub? Hub uses IP address. Now what happens when a sender wants to send a message and doesn't know the exact location of the address or doesn't know the IP address? What happens? The message will be broadcasted to all the computers. So this is about broadcasting. So this has been removed in IP version 6. IP version 6 enable device to self-acquire an IP address and communicate with that subnet. So it can communicate with a subnet. So IP address contains the address, and with that we have a subnet. It is a kind of a address that we use for communication. This auto configuration removes the dependency of dynamic host configuration protocol server. Now IP version 4 removes the dependency of dynamic host configuration protocol. Now what is this? Now whenever you open a browser or you go to any website, you will get a IP address that is dynamic. So every time the IP address gets changed, that is nothing but dynamic host configuration protocol. IP version 6 provides the new feature of IP6 mobility. Mobile IP version 6 equipped machines can roam around without the need of changing their IP address. Now in IP version 4, we have broadcasting, and every time what happens when you open the website again and again, IP address change. But in IP version 4, once your IP address is there, your IP address will not change and you can roam around with the same IP address. IP version 6 is still in transition phase and is expected to replace IP version 4 completely in coming years. Now it is still in the transition phase. That means it is still in a working phase and is expected to replace IP version 4 in coming years, maybe in 5-6 years or more. Let's see. Now there are some transition mechanisms available for IP version 6 enabled network to speak and roam around different networks easily on IP version 4. Now these are dual stack implementation, tunneling, and NATPT. So this is about Internet Protocol version. Domain name system. Domain name system. For communication over the Internet, we can use IP address. But it is not possible to remember the IP address of a particular website or computer every time. Say for example, Google has certain IP address. Say the IP address of Google is 192.06.01.02. So every time if you type on a Google bar, address bar, the IP address, it is not possible. So domain name system made it easier to resolve the IP address into names. For example, google.com, facebook.com, cbse.nic.in, etc. So these are nothing but a domain name which have their own IP address. So in domain name system, what happened? The IP address has been put to a name so that people can recognize it. Now it is a system which assigns name to some computers and maintains database of these names and corresponding IP address, which is called as domain name resolution. Now like google.com. Now Google will be having some IP address, say for example 192.06.02.01. So this is the IP address of Google. Now this IP address will be stored in the database with a certain name as Google. So this is called as domain name resolution. Domain names are used in URLs to identify particular web server. For example, in the URL https www.cbse.nic.in/welcome.htm, the domain name is www.cbse.nic.in. So this www.cbse.nic.in will have certain IP address. Now we cannot type the IP address every time. So it is easier for us to remember the cbse.nic.in. So this is nothing but a domain name system. Now a domain name consists of the following parts: top level domain name or primary domain name, and number 2, subdomain name. For example, in the domain name cbse.nic.in. Now from cbse.nic.in, this .in is the primary domain, NIC is the subdomain, and CBSE is the subdomain of NIC. Now generic domain names. These are the top level domain name and occur at the end of a fully qualified domain name. These are .com. Now .com is used for commercial business. You may have seen in online shopping shop like Amazon.com or Flipkart.com. These are all commercial business. So if you're creating a commercial business, you will use .com as your generic domain names. .edu is used for educational institution. .gov for government agencies. .mil for military. .net is used for network organization. .org is used for organization, that is non-profit organization. So these are the generic domain names. Country specific domain name. These are also top level domain name and occur at the end of a fully qualified domain name. These are .in, that is used for India. .au is used for Australia. .ca for Canada. .ch for China. .pk for Pakistan. .jp for Japan. See for example Google. If you type www.google.in, that means you're using Google from India. Or if you're typing www.google.us, that means you're using Google from US. So these are nothing but a country specific domain name. URL structure. Now the URL structure defines 4 things: protocol, host, computer, port, and the path. The protocol is a client or server program used to retrieve the document, like HTTP. Here HTTP or HTTPS is a protocol which is used to retrieve the document. Now many different protocols can retrieve the document. Among them are FTP or HTTP. The most commonly used protocol today is HTTP. Now the host is the computer on which the information is located, although the name of the computer can be the alias name. For example, here in the picture you can see www.domain.com. So this is the host. Say for example www.facebook.com or www.google.com. These are nothing but the hosts. Web pages are usually stored on computer, and computers are given alias name that usually begins with the character www. Here in this picture you can see from the host www.domain name. Here you can see that the alias name starts from www. The URL can optionally contain the port number of the server. Now sometimes in certain websites you have a port number, but most probably you will not see a port number. So a port number can be like 1, 2, 3, 4 or any number that is located on the server. If the port is included, it is included between the host and the path and is separated from the host by colon. Now from the picture you can see the host is www.domain.com and the path is path to resource. So in between we have a port number 1234 which is separated from the host with a colon. Now the path is the path name of the file where the information is located. Here the resource path is path/to/resource. So this is nothing but a URL structure.